Exam review number 3, question number 13. Convert the polar coordinates 8 and 7 pi over 6 to Cartesian coordinates. So r is 8 and theta is equal to 7 pi over 6. And now we need to find x and y. We know that x is equal to r cosine theta, which is going to be 8 times cosine 7 pi over 6. We know this is equal to 8 times negative square root of 3 over 2. Cosine 7 pi over 6 is negative square root of 3 over 2. So if you reduce the 8 with 2, you're going to get negative 4 square root of 3. Now the y is equal to r sine theta, which is 8 times cosine 7 pi over 6. And this is equal to 8 times negative 1/2, which is equal to negative 4. So here is the x and here is the y, which makes the coordinates now negative 4 square root of 3 and negative 4. Question number 14, we need to convert the Cartesian coordinates negative 1 and 6 to polar coordinates and make sure you are working in radians mode. We know that r is equal to the square root of x squared plus y squared. And before we start that, actually, let's determine in which quadrant is this point. This point is negative 1 and 6, which means it's going to be in the second quadrant. So we're working in the second quadrant in this case. This is equal to the square root of negative 1 squared plus 6 squared, which is equal to 1 plus 36. That is square root of 37. I can just leave it like this. And then theta is equal to the inverse tangent of y over x, which is 6 over negative 1. So I'm going to plug that into the calculator, and that is in radians mode. So theta is equal to, so this is going to be equal to negative 1.41. Okay, negative 1.41 is approximately here. And we need to find the positive value. So we're going to add a full pi to get it back into the same quarter here. So we're going to say plus pi, which is going to be 1 period for tangent. And that is going to give us 1.74 radians. So again, this answer right here basically is going to give us an angle in the fourth quadrant. So we need to add 1 period from tangent to that. We know 1 period of tangent is pi. So what we did here, we added 1 pi to get it back to the second quarter here. And the answer is 1.74. So that is question number 14. Question number 15. We need to rewrite the equation. Let me just make a line here. And I'm going to do number 15 right here. We need to rewrite the equation y equals 4x squared in polar equation, as a polar equation. We know that x is equal to r cosine theta. We know that y is equal to r sine theta. So we're going to replace x and y by their values. Y is r sine theta equals 4 times r cosine theta all squared, which is r sine theta equals 4r squared cosine squared theta. We're going to gather all of the terms to one side. R sine theta minus 4r squared cosine squared theta equals 0. I will factor r out as a common factor. Sine theta minus 4r cosine square theta equals 0. Now, I can basically remove r, divide both sides by r, and I can remove r. So this will be gone. I will have sine theta minus 4r cosine theta equals 0. Our goal is to solve for r. So I'm going to try to add 4r cosine theta to both sides of the equation. So I will have sine theta equals 4r cosine theta. I'm going to divide both sides by 4 cosine theta so I can isolate the r. 4 cosine theta. So I will have 4 cancelled, cosine cancelled, and on this side I will have r equals sine theta over 4 cosine theta. Cosine squared actually here. So the final answer is r of theta is equal to sine theta over 4 cosine square theta. And that is the final answer for that one. Question number 16, we need to match the graphs with the equations. The first equation I spot here is the equation of the circle. This is an equation of a circle. It's of the form r equals a cosine theta. I know this circle is going to be on the y-axis. The center is going to be half a and 0. So the center is 1.5 and 0. And the radius is going to be a, which the diameter is going to be a, which is in this case 3. So d is going to be the equation c, which is, I'm going to write the equation here. So this is r equals 3 cosine theta. The first graph here, A, is a limison, a dimpled limison. We know for a dimpled limison, A has to be bigger than B. And since it's on the polar axis or the x-axis, this axis right here, I know that it's going to have a cosine. And if you count the numbers, you'll see that 1, 2, 3, 4, 5, 6, 7, 8. That is basically B plus A is 8. So immediately I can see that D might match that. Let me just highlight it differently here. So D, let's check out D. B plus A, 3 plus 5 is 8. B minus 5 is negative 2, which is the other side. So this is the other side, which is negative 2. So yes, this is D, which is the equation r equals 5 plus 3 cosine theta. This is dimpled limison. Graph B is a one-looped limison, which means A is less than B. So immediately my attention came to equation number A, this equation right here. First of all, B plus A is 5, and I have 1, 2, 3, 4, 5, which is this point. This point is 5. And then B minus A is 1, which is basically the end of the loop of the limison right here. So A matches graph B, and the equation is r equals 2 plus 3 cosine theta. C is a cardioid, and the cardioid will have A equals to B. So here, A is equal to B. Here is A, and here is B. A is equal to B, and that is the only cardioid I can see here. So this is immediately B, and the equation is r equals to 3 plus 3 cosine theta. The last one here is another dimpled limison, and the remaining equation matches. So a is bigger than b plus a is 10, which is this point, and then b minus a is negative 4, which is this point. So that matches, and E matches equation E, and the equation R equals 7 plus 3 cosine theta. So that is the matching for question number 16. Number 17, this is a rose curve.